there's always a process in the teardown that I do. And it's very, very important when you're troubleshooting and diagnosing compressors that you use the same process. It'll make it go quicker and faster for you. For step one for me is scanning the serial model number with Copeland Mobile. Because if the compressor's not running anyway, you want to check the windings to see if the electrics are good. So you scan the compressor on Copeland Mobile. This is a 3DS3R. And what you want to do is put it on ohms. This one here is supposed to be about 1.4 ohms. I've checked it already. And I always like to go right on the tips. So I got 1.5, so that's bang on. Oh, here we go. I got 51 on that one. And then 51 on. So there's something going on with this winding right here. Let's try to ground to see if. So look, I got resistance to ground on that winding. This one has a short. And this one has a short. So we got resistance to ground. So there's an issue with this compressor. But before you just say every time, oh, the windings are gone, sometimes, I've taken it apart to make it a little bit quicker, sometimes you get a short between the windings, and it's because of this electrical insulator. So you always want to check this electrical insulator, see if it's cracked, if it got carbon tracking or something. It's definitely in low temp applications. We've seen it a lot more when there can be condensation built up on it. Then you want to check it again. That one's winding is still good, but that one you have resistance and then going to ground. Well, these two windings are going to ground. But you also want to check this insulator plate right here to make sure it's not this, because it could be this. I've seen many compressors come back, big ones as well, 6D compressors come back, and it's just this insulator. Another thing you need to be aware of, just say it is the insulator that is bad. This here goes right inside to the compressor. As you can see, moves a little bit. If you all of a sudden put a new insulator on and you crank this down as hard as you can or really tight, you could break this, or even worse, break it on the inside here. And we've seen that happen before. So there is our bolt torque. I think it's AE 1219. I'll have to double check that, but our bolt torque spec, go into application engineering, bolt it, and see what this is supposed to be. Is this 50 pounds? Is it 60 pounds? And double check that, because we've seen that damage before. So we know electrically the compressor failed, but what caused electrical failure? As I talked about earlier in the presentation, 80% of the time, technicians say that this is electrical failure, it's a burnout, which caused the failure, but that is the second cause of failure, electrical failure. 80% of the time, it's a mechanical failure. So we check the electrics, we know the electricals are bad, but you don't want to stop there. You want to figure out why the compressor failed. Why is the electrical fails on this compressor? Before you pull off the head, there could still be pressure underneath here. On discus compressors, this is all high pressure. Take this out if you can. Pop that out. And if you hear at least there's no gas left in there, because we've seen it before where guys pull off all the head, they take the hammer, they hit it, and then all of a sudden they're splashed with oil because there's pressure under there. Another way to do it is leave 2 bolts in. Don't have them very loose, but loose enough to be able to bang it off. So 2 bolts still in there, knock it off and take it out. When I first opened this, because I did a training with the Copeland technical specialist on this last week, and this wasn't open. This was not inspected, this head. It wasn't taken off. So first thing you want to do after you get the head off is take a look at this gasket here. See what it looks like. Kind of looks dry, but it's not busted. There's no, head pressure, a blown head gasket. So you want to take that off. It looks okay. But when you get down here, we see we see some darkness, right? A little bit of heat right here, because discoloration right there. But then you see a lot of black. Like I said in the presentation, if you can clean this off, and see how I'm cleaning this all off, and it's back to its regular color, that's mechanical wear. What causes that? Mechanical wear. So it could be rings, it could be pistons, whatever it is, where that made it up through here. So next step is taking this off and checking this side. So there you go. So what do you see? What do you think caused this? And what I hear all the time, like I mentioned earlier, is liquid. It's liquid. It's liquid. Well, what type of liquid? Was it oil? Was it liquid refrigerant? And what do you mean by liquid? Was that liquid from a floodback situation? Was that liquid from a flooded start situation? Was that liquid from a slugging situation? So there's so many things. You really need to understand which one it was, and that will help you fix the problem. So we see this suction here, damage out here, a piece of it's inside here, the discus puck. The pucks are still good, and you see here, this one's damaged here. So after this taking a slug, I'm assuming this one took the first slug and broke, and then caused the rest of them, maybe this one broke at the same time. All this black stuff up here is this pieces of the suction reed, okay? And when we look under here, when we take a look under here, we can see, let's see if we can pump this, we can see parts in here. So because the pistons are so damaged up, you're gonna have to replace this compressor. But not always. Sometimes, if it takes a slug, you can just replace the head on it. But you do need to inspect to take a look, because this is a slug. But what caused this slug? You know, how did it slug? We'll go through that in a few minutes. So after you determine that, okay, taken a slug, we look inside, okay, we can't just replace the head gasket, or sorry, just replace the valve plate because there's so much damage in it. You should just still keep going. You shouldn't stop there. You should the next step is taking off the oil pump. And why you want to take the oil pump off is, like I talked about earlier, shaking hands with the crankshaft, as well as checking wrist pin wear. So when you pull off the pump, you want to make sure you look inside here to see if there's any gouges, any copper. It looks all good inside there. It's kind of dry in here. It's kind of dry, but it looks okay. So that's the pump housing I pulled off. And then over here, you may not be able to see it. I'm going to just move over a little bit. So you can have play back and forth just like this. You don't want any play up and down, called shake hands with the crankshaft. And there's really no play up and down. Back and forth, there's play. And you want to check, because what the whole purpose of that is check this main bearing. If you have a worn main bearing, that is due to floodback, which drops that rotor. So this is an example here. As you can see, that progressive wear that we talked about earlier in the presentation, to where this bearing now is on here. This should be in the housing. There's even a little bit of copper plating happening there. But what you would do is shake hands with the crankshaft, and if there's a lot of up and down play like this, that electrical failure would have been due to this main bearing wore dropping the stator onto, dropping the rotor onto the stator, getting rotor drag. The other check you want to do before you finish, you already got the pump out, is doing the wrist pin check. And how you do a wrist pin check, you put it up top dead center, turn it a little bit, and push down. So it didn't drop there. Didn't drop there. And didn't drop there. Like I talked about earlier, if you get a slug and it takes out the discharge, right? It takes out the discharge. You have that discharge pressure pushing down on the piston, right, like that. What will happen is that you get wrist pin wear. Maybe hard to hear there, but this is exactly what happens. Right here, if you could hear that, that's wrist pin wear due to busted discharge, not getting enough oil up into the piston, wrist pin, and you get a failed wrist pin. And if you get a knock in the compressor, and just say all of a sudden once, oh, I just got this busted, the cylinders look good, but I'll just replace the valve plate. What's going to happen is you're going to spend a lot of money replacing the valve plate, but the customer's going to call you back in a few months and say, man, that compressor's way too noisy. You need to replace it. So just be aware. This is why to do a little bit more diagnostics on the compressor just to make sure. So once again, check the electrical. If you have a failed electrical or not, pull the head off. Inspect the top, inspect underneath, inspect the cylinders and pistons, pull the pump off, inspect the pump itself, pull the pump housing off, inspect the pump itself, and check the wrist pin. Check the wrist pins and check the main bearing. Those are your main checks. So yes, I did have the bolts off already to speed this up. But I've done a compressor right beside me here, and you're technicians. You know how to work it. You can have your impact gun to unscrew everything off there, have it pumped down properly, have it locked out properly. It doesn't take you an hour, 2 hours to do this. You could do this in a half an hour or less to find out exactly what happened. And now let's talk about what happened here. We got an electrical failure. Yes, the compressor's not going to start electrical failure, but we have that electrical failure because of a slug. And that slug was due to what? Migration. System migration. That refrigerant migrated back to here, filled up inside the compressor. The compressor started up, and refrigerant-cooled compressors, when you have a massive flooded start, takes a slug. So there's three things. Electrical was caused by a flooded start, which had a slug. So there's a process in the troubleshooting. Just remember that. Try to figure out the process. We are detectives, and we need to understand exactly why that compressor failed. So when tearing down a scroll, it takes a little bit more time because you do have to cut it open. What I use is a Sawzall and a good Sawzall blade, and I cut right underneath the weld. That is how we do have a cutter right here, right beside me. But that's where you want to cut on a standard scroll compressor. Your first step, though, is reach out to the Copeland authorized wholesaler and see if it's still under warranty. If it's not under warranty, you can cut it open. If it's under first warranty, talk to them, ask them if you can still cut it open to find out what's wrong with it. If they don't have to send that compressor back to Copeland, there's no reason why you can't cut it open. But just make sure with the Copeland authorized wholesaler. And I highly recommend doing this back at your shop. So no different than the semi-hermetic we just did. The first thing you want to do is check the winding resistance. So this is a ZR38K5. The model number was taken off, but I checked it on Copeland Mobile. Common to start was supposed to be 1.395. .5, I'll say that's good. And then common to run was supposed to be 0.57. I say that's good. And now let's go to ground. OL. OL. And OL. So this leads me to believe that the windings are okay. So next step, after you cut it, flip it over and take a look. And if you look, I've been doing a lot of teardown, so I notice a lot of things. But flipping this over, here's that high internal pressure relief right there. But when I looked at this, I see a lot of heat right here, a lot of heat. And then I see this ring. And if you tear down enough scrolls, this ring will be here, but not that color. What do you think that is? Okay. And then this is the floating seal. This is where everything happens, like I talked about. This floating seal has pressure coming from underneath it to balance this out. It pushes this up against the muffler plate, because this is the muffler plate, so it can push down the fixed scroll or stationary scroll so they can engage the flanks. But even looking at this right now, I can tell it has a funny color to it. Can anybody tell what that color is? I am sure most of you have seen it already. So what you want to do is pull off the floating seal. 2 screwdrivers usually work too, and look under. I see a pile of heat here. A pile of heat. And then this is anti-rotation device for shutdown. But see, this is the internal pressure that pushes up on this, which pushes this against the muffler plate to balance out this. But we see a ton of heat on there. Some scrolls have 3 bolts, some have 4 bolts. And some spacers. So your next step is to pull this off. Wow, what an amazing example this is. As you can see, all that color in there. It looks like copper, doesn't it? And then on these spacers, look at all that. What causes copper to be in a compressor? It's called copper plating this. Let's take a look here. More. Major copper plating. This failure is due to improper installation. As you can see, a ton of copper in there. Don't see too much. There's a little bit of scroll galling, but nothing too serious. A little bit of scroll galling down here, nothing too serious. Bearing looks great besides all this copper plating on it. Okay? So contamination caused this failure, as you can see in here. And look how easy that spins. You should always check that to make sure it spins really well. And if you get a compressor like this, all of a sudden the windings are good. I went a step further. We always go a step further here at Copeland. We check it with a high pot test, and I checked it, and it fails a high pot test. So sometimes, even though the windings on your meter reads correctly, your windings can still be broke down and failed. And actually, I'll do a quick check with that. Because we pass it, instantly trips it off. So this compressor failed from contamination. Can anyone tell me what they have to do to fix this? Or what they should have did in the first place? Pulled at a good evacuation. Down below 500 microns holding, down below 250 microns and held. Other things you want to check is this is the Oldham coupling. See, make sure this is not broke. If this is broke, that's mostly due to a slug. If it was flooding back, just like the presentation says, here's an example here. If you pull it apart and this is what it looks like, this is due to flood back. Liquid refrigerant returning to the compressor while it's running. The bearing's just destroyed. And the bushing, I don't have the bushing for that, but I bet you it's banged up real good. Compared to this one that looks brand new. I've seen compressors 8, 9, 10 years come out and they look like this. And then we talked about flooded starts. It may be hard to see, but you see all that scroll galling in there? Right? So this one here, the bearing's perfect. We can tell that this one didn't have really any flood back. All this here, that we can see the scroll galling in there, that is due to flooded starts. That compressor starting up and getting refrigerant washing away the oil, but not having any damage down here. And vice versa. If you see this damaged up real bad, just like this, and it looks totally fine on the inside or pretty good, that means it was only flood back. So let's get back to the presentation.